Our topic is all about electromagnetic spectrum. This is the topic for grade 10, and I will be your instructor for the day. Yours truly. Okay, so before we proceed to electromagnetic spectrum, we must learn how to define what is an electric wave. There you go, electric wave. So when we say electromagnetic wave, it is what? Transverse waves without a medium. They can travel through empty space. So an electromagnetic wave can travel through anything, be it air, a solid material, or vacuum. It doesn't need a medium to propagate or travel from one place to another. Mechanical waves are like sound waves or water waves. On the other hand, need a medium to travel. EM waves are transverse waves. So what does it mean? This means that they are measured by their amplitude or height and wavelength or the distance between the highest or lowest points of two consecutive waves. The highest point of wave is known as crest, whereas the lowest point is known as trough. Electromagnetic wave also travel as vibrations in electrical and magnetic fields. Electromagnetic waves or EM waves are waves that are created as a result of vibrations between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields. Electromagnetic waves have some magnetic and some electrical properties to them. Electromagnetic waves are formed when an electric field comes in contact with a magnetic field. They are hence known as electromagnetic waves. When an electric field changes, so does the magnetic field. The changing magnetic field causes the electric field to change. When one field vibrates, so does the other. So this means that the electric field and magnetic field of an electromagnetic wave are perpendicular to each other, meaning they form a right angles. They are also perpendicular to the direction of the EM wave. As a result, the outcome is an electromagnetic wave. Also, electromagnetic waves travel very fast, around 300,000 kilometers per second, or that is equivalent to the speed of light. At this speed, they can go around the world 8 times in 1 second. Imagine if you were an electromagnetic field, you can travel 8 times in 1 second all over the world. EM waves travel with a constant velocity of 3.0 times 10 raised to the power of 8 meters per second in vacuum. They are deflected neither by the electric field nor by the magnetic field. However, they are capable of showing interference or diffraction. Next. So, is the electromagnetic a wave or a particle? Electromagnetic radiation has properties of waves, but also can be thought of as a stream of particles. For example, light. So we have here light as a wave. Light as a wave, light behaves as a transverse wave, which we can filter using polarized lenses, and also light as particles with photons. When directed at a surface or at a substance, light can knock electrons off of a substance, also known as the photoelectric effect. So that's it. Next, we will proceed to electromagnetic spectrum. What does electromagnetic spectrum mean? So it is a name for the range of electromagnetic waves when placed in order of increasing frequency. So electromagnetic waves can be split into a range of frequency. This is known as the electromagnetic spectrum. Examples of electromagnetic waves within electromagnetic spectrums are radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, and we have the gammas, gamma rays. To memorize this electromagnetic spectrum, we will use the acronyms RMIVUXG, or we will put some meaningful words on them. So let's say Raoul's mother is visiting Uncle Xavier's garden. So we have here Raoul's Raoul's mother is visiting Uncle Xavier's garden. Raoul's mother is visiting Uncle Xavier's garden. Raoul's with a letter R stands for video. Mother, micro, is infrared. We have visiting, visible, angles, ultraviolet, Xavier's X-rays. We have garden, gamma rays. So that's it. So the electromagnetic spectrum is a range of all types of EM radiation. When we say radiation, it is an energy that travels and spreads out as it goes. The visible light that comes from a lamp in our house and the radio waves that come from a radio station are the two types of electromagnetic radiation. The other types of EM radiation that make up the electromagnetic spectrum are microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. You know more about the electromagnetic spectrum than you may think. So the image shows where you might encounter each portion of the EM spectrum in your day-to-day life. So notice the wavelength is longer or longest in what? In radio waves. That is about the size of a buildings or humans and gets shorter as it goes to gamma rays. So if we are going to analogize the distance of gamma ray, so we have here it is being comparable to atomic nuclei, whereas visible light is comparable to protozoans. We have the microwave that is visible, comparable to honey bee. That's how their distance or length is when we talk about their wavelength. Next, electromagnetic spectrum. So we have here on the image. So we have the radio waves, the microwaves, infrared, the visible light, ultraviolet X-rays, hot X-rays, and we have gamma rays. So as you notice, when it comes to wavelength, it is in meters. In meters. So the longest wavelength is on the radio waves, and the shortest wavelength is on the gamma rays. When we talk about the frequency, so frequency is waves per second. So we have here the shortest frequency is on the radio wave with the longest wavelength, and the highest frequency is on the gamma rays, which has a shortest wavelength. Therefore, we can make a conclusion out of this that the longer its wavelength is, the shorter its frequency. Or the shorter the wavelength is, the highest the frequency. Got it? Okay, so we have the energy of one photon, that is electron volts. So if you have the lowest energy of one photon, that means you have also the lowest frequency. And if you have the highest energy, you have the highest frequency. So that means that frequency and energy of one photon is what? Is directly proportional. As one gets increasing, the other also increasing. And as one wave decreases, its energy is decreases. So frequency here and energy is directly proportional. Whereas frequency and wavelength is what? Inversely proportional. When one gets increasing, the other gets decreasing, and vice versa. So we will discuss each electromagnetic wave within electromagnetic spectrum. The first one is we have the radio waves. Radio waves has the what? Has the longest wavelength of EM waves. Example, this and that. The radio signals, and we have the MRI. When do we use radio waves? So radio waves is used in TV broadcasting AM and FM broadcast radio, heart rate monitors, also used in cell phone communication, and we have the MRI or the magnetic resonance imaging. So radio, your radio captures radio waves emitted by radio stations, bringing your favorite tunes. Radio waves are also emitted by stars and gases in space. A radio picks up radio waves through an antenna and converts it to sound waves. So each radio station in an area broadcasts at a different frequency. So the number on radio dial tells the frequency. Oh, wait. Okay. Were we? No. Okay, sige. So let's proceed to microwaves. Microwaves have the shortest wavelengths and the highest frequency of the radio waves. For example of that is this rotor, and we have the Bluetooth headset. The Bluetooth headset. When do we use microwaves? Microwaves can be used in microwave ovens, Bluetooth headsets, broadband wireless internet, radar, and GPS. So microwave used in microwave ovens. Waves transfer energy to the water and the food, causing them to vibrate, which in turn transfers energy in the form of heat to the food. So that's how microwaves is being used in microwave ovens. So microwave radiation will cook your popcorn in just a few minutes, but is also used by astronomers to learn about the structures of nearby galaxies. It can be all used in we have radar. What is the meaning of radar? RADAR. So it is the acronym for radio detection and ranging. So it is used to find the speed of an object by sending out radio waves and measuring the time it takes them to return. Also, it is used for GPS. So what does GPS stands for? It stands for Global Positioning Systems. Again, GPS is Global Positioning Systems. So it measures the time it takes a radio wave to travel from several satellites to the receiver, determining the distance to each satellite. So that is microwave, and this is the wavelength of microwaves. So it is ranges from 30 centimeters up to 0.3 centimeters. Next, electromagnetic wave within electromagnetic spectrum. Raoul's mother is, so we have the infrared, infra, and red, meaning below red. So wavelengths in between microwaves and visible light. It has shorter wavelength and higher frequency than microwaves. So we have here the night vision goggles and we have the microphone. When do we use infrared? Infrared is used in, we have night vision goggles, remote controls, heat-seeking missiles, and thermogram rather. So infrared is used in night vision goggles, wherein it picks up the infrared light emitted by our skin and objects with heat. In space, infrared light helps us map the dust between stars, so you can feel the longest ones as warmth on your skin. Warm objects give off more heat energy than cool objects. So also we have thermogram. So thermogram, a picture that shows regions of different temperatures in the body. Temperatures are calculated with amount of infrared radiation given off. We have here the hand water. So therefore, people give off infrared rays, and we have heat lamps give off also infrared rays. And this is the wavelength of the infrared. So that is in between of 3 micrometers. So that is smaller, much more smaller than the what? The the what? The microwaves. Okay. Next. Next is visiting V. So we have the visible light. Visible can be seen. So visible light is what? Is the only type of EM wave able to be detected by the human eye. Example is rainbow. We have the prism. So shorter wavelength and higher frequency than infrared rays. It is the only electromagnetic waves that we can see. Yes. So we have here violet as the highest frequency light, and we have the red light as the lowest frequency light. It is visible. Our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible light. When light enters a new medium, it bends or refracts. The process is refraction. Each wavelength bends a different amount, allowing white light to separate into its various colors. What is that? Various colors. So we have the ROYGBIV or ROYGBIV. ROYGBIV. We have the red, orange, yellow, green, blue, indigo, and we have the violet or purple. Okay, next. So we have the wavelength of a visible light. So this is the region of the visible light within electromagnetic spectrum. So that is between 0.7 micrometers to 0.4 micrometers. So after visible light is ultraviolet, and before that is we have the infrared, Roy G. Beef, red beef, we have violet. Next, we have anchor ultraviolet rays. So what is ultraviolet rays? Shorter wavelength and higher frequency than visible light, and it carry more energy than visible light. For example, is one. Okay, when do we use ultraviolet rays? So ultraviolet rays can be used in black lights, security images on money. We have the harmful to living things also used to sterilize medical equipment. Too much causes sunburn. That extremely high exposure can cause skin cancer. So ultraviolet radiation is emitted by the sun, and the other reason skin tans and burns. Hot objects in space emit UV radiation as well. It can be used to kill bacteria in the process of sterilization. Too much can cause skin cancer, but it can use sunblock to protect against UV rays. We can use sunblock to protect against UV rays, but despite of being harmful, there are some benefits of ultraviolet rays. One is causes our skin to produce a vitamin D, which is good for teeth and our bone. Okay, ultraviolet rays can cause skin diseases, but we can use sunblock. This is the range of ultraviolet rays within the electromagnetic spectrum. So it is between of 0.3 micrometer and 30 nanometers. Angle saviors letter X. So that is X rays. What is an X-ray? So X-rays are tiny wavelength, high energy waves. So it has shorter wavelength and higher frequency than UV rays and can carry a great amount of energy and also can penetrate most matter. So that is our neck, bones of our neck. So when do we use X-rays? X-rays can be used in medical imaging, airport security, moderate dose can damaging to cells. So a dentist uses X-rays to image your teeth, and airport security uses them to see through your bag. Hot gases in the universe also emit X-rays. How about bones and teeth? So in bones and teeth absorb X-rays. So the light part of an X-ray image indicates a place where the X-ray was absorbed, used by engineers to check for tiny cracks in structures. So we have here an example, the bone. So this is the image of a bat through an X-ray. So we have also a concrete sample. So X-rays are also used by the engineers to what? To check for tiny cracks in structures. So how does it goes? So the rays pass through the cracks and the cracks appear dark on film. So that is how it goes. And this is the region of the X-ray within electromagnetic spectrum. So that is from 3 nanometers up to 0.03 nanometers. So it's very tiny compared to ultraviolet rays. The last one, garden. We have letter G, stands for gamma rays. So what is gamma rays? Gamma rays has a tiny wavelength, high energy waves. So that's it. So gamma rays has a shorter wavelength and higher frequency than X-rays, and it carry the greatest amount of energy and penetrate the most. So gamma ray, doctors use gamma ray imaging to see inside our body, and the biggest gamma ray generator of all is what? Is the what? Is the universe. So the biggest gamma ray generator of all is the universe. Why do we use gamma ray? Gamma rays can be used in what? In sterilizes medical equipment and cancer treatment to kill cancer cells. So it is used in radiation treatment to kill cancer cells, but can be very harmful if not used correctly. Exploding nuclear weapons emit gamma rays also kills nearly all living cells. So we have here exploding nuclear weapons emit also gamma rays. And last one, trivia. Don't you know? Do you know the green one? Okay, that is familiar to you. And that is Incredible Hulk. Don't you know that Incredible Hulk was the victim of gamma radiation? And this is the region for the gamma ray within the electromagnetic spectrum. It ranges from 0.03 nanometers up to 0.03 nanometers. And to summarize our topic, so we have all electromagnetic waves travel at the same speed, that is 300 million meters per second in a vacuum, or that is 3.0 times 10 raised to the power of 8 meters per second. And we have all electromagnetic waves have different wavelengths and different frequencies. So what can we say about the wavelengths, or what can we say about the relationship of wavelengths and frequencies of all electromagnetic waves? We have long wavelength is equal to lowest frequency. So long wavelength means lowest frequency and short wavelength means highest frequency. So meaning the higher the frequency, the higher the energy. So this is the last slide for today. So hoping na marami kayong naiintindihan and to please help me to have more updating videos and informative videos. Um, please subscribe and like and share these videos to all so that our other students can also see this video to better understand the electromagnetic spectrum. Thank you and God bless us all.